Once upon a once upon a time, the Earth was dominated with science students, known as Igwa. Using their superior brains and technology, the world was dominated by such students. People were at states where they were so rational that their emotions started to disappear and lived like robots. The four last liberal arts students, Sean, Andy, Daniel, and Jeff, worked for night and days to save the world from this calamity. Then they heard that deep inside MIT, Nichin Inqa Techies, there was a hidden hero who has powers to save the world. Now these liberal arts students are going for their journey to save the world.
Everyone, turn to page 131. We're going to learn about advanced three-dimensional trigonometry. So if we have a z-axis, x-axis, and a y-axis, we're going to model two right triangles. And we have, as you can see, a right triangle from the y-x plane, and also a right triangle from the x plane right here. We're going to perform a spherical integration for all of these guys, an integration of the Gaussian sphere. As you might see, so it's linear independence, and then we're going to you have to screw this. Let's go.
You guys are before the last Mungwas. You can't pass this unless you resolve this problem.
I wrote this.
Determine the acute radial Tuesday.
I remember it from geometry. Let's see the question. Determining acute and obtuse angles relies its basis on the Pythagorean theorem. The Pythagorean theorem states that if you have a right triangle, like so, you can get the following equation. And consequently, the inverse of that theorem tells us that once a triangle matches this equation, the triangle is a right triangle. Because of this, once used in a variation, we can know that whenever c squared is larger than b squared plus a squared, the hypotenuse c is longer than that of when the triangle is a right triangle, making the angle larger than 90 degrees and consequently making it an obtuse triangle. The same principle is used when determining an acute triangle. If c squared is smaller than a squared plus b squared, it will mean that c is shorter than the case when the triangle is a right triangle, making the angle smaller than the right angle, and consequently making the triangle an acute triangle.
How look is this?
Don't touch it, it might be dangerous.
Came here for the stone, you'll not get what you want, because my orange stone is inevitable. You dare make fun of me? This geometric question will wipe the smirk off your face.
Talk about the inverse operation in trigonometry. The original operation is written like this. The inverse operation is the reverse to this operation. And in the inverse operation, the ratio of the size goes inside these parentheses, and the angle measure goes on the right side of this equation. So these two swap their places in the inverse operation. Now, to give an example of how this inverse operation is used, let's take a look at a right triangle with the hypotenuse with the measure of 2 and with one leg with the measure of root 3. Now, I've deliberately set it as the special triangle so that we know that this angle is 60 degrees, but let's assume that we don't know about the special triangles. And let's say that this angle has the measure of 80 degrees, and here we should be using the inverse operation. So to do that, we first go with sine -1, sine -1, and inside these parentheses we put the ratio of the sides. So it's opposite over hypotenuse, opposite root 3 over hypotenuse, which is 2, and this should equal to A. And if we type in this value into our calculator, we get 60. So we can conclude that A is 60, and this is how you use the inverse operation in trigonometry.
So this question is indicate the angle of depression. And we know that the angle of depression is opposite of the meaning of angle of elevation. Thus, it will be if you look down an object, the angle your line of sight makes with an object is the angle of depression. So in this case, looking at the eye level, the angle of depression will be right around there.
How dare you?
Damn you, Cole.
What, the monster is really pink?
Yeah, only due to us. Oh, I'm scared.
I will give you guys the mask unless you guys solve this question.
Geometry means and special triangle.
What does geometry mean?
Oh, I know it. Geometry means are root of two multiples. In geometry, there are two types of geometry means: leg geometry mean and altitude geometry mean. Both have the exact same concept, but differ in what you're finding the length of. For altitude geometry means, it states that in the right triangle, the length of the altitude from the right angle is the geometry mean between the two segments that form the hypotenuse. So in this case, you're looking for the length of the altitude from the right angle using geometry means. Leg geometry mean states that in the right triangle with an altitude drawn from the right angle, the length of each leg is the geometry mean between the whole hypotenuse and the segment of the hypotenuse that is adjacent to the given length. So in this case, you're looking for the altitude drawn from the right angle, which are the legs of the biggest right triangle. But let's shorten it down to a more simpler concept. All of what we're finding in altitude geometry means and leg geometry means are all altitudes in a bigger scale. The legs AB and CB are altitudes or heights of the biggest triangle ABC, and BD is also the altitude of ABC. So in reality, all of these are just altitude, which their lengths are determined by the geometric mean of the two segments that share endpoints with the altitude and are on the hypotenuse of the biggest triangle ABC.
And what are special triangles?
Oh, I know how to do it.
There are two types of special triangles. A right triangle with 30, 60, 90 degrees, and a right triangle with 45, 45, and 90 degrees, which is an isosceles. The segments, adjacent and opposite, are determined by two other angles other than the right angle. The hypotenuse will be the longest segment of the right triangle. If the according angle is theta, sin theta will be opposite over hypotenuse, cosine theta will be adjacent over hypotenuse, and tangent will be the ratio of opposite over adjacent. In the 30, 60, 90 right triangle, the ratio of the three segments will be 1, 2, and square root 3. In 45, 45, 90 right triangle, since this is a isosceles triangle, two segments will be 1, and the hypotenuse will be square root 2.
3 minutes left. I solved it!
How did you solve this?
You said I'm not past this!
What should we do now?
We don't have man Daniel now.
Even though we have a small chance to solve the trick questions. I mean, we owe it to Daniel, who's not in this room, to try. We must defeat the mastermind of this play.
Just like that?
Yeah, just like that.
Then what are we waiting for? Let's go get this son of a...
You guys are finally here. What you guys want is hidden here. You shall not pass! You guys challenged by cosine?
I can do this all day.
Assemble. Assemble!
Now we are going to explain about the law of cosines. Let's say you had a triangle. Well, let's say the only things that you know were two of the three side lengths and the angle measured between them. In this case, the law of cosines comes in handy, and it helps us figure out the length of the third side. Let's take a look at the formula of the law of cosines. If there's triangle ABC, the c squared is equal to the square of a plus the square of b minus 2 times a times b times the cosine of c. This part is where the cosine comes in, and that's why it's called the law of cosines. The law of cosines works in any triangle, so it doesn't matter whether you have an acute triangle, a right triangle, or an obtuse triangle. The law of cosines works for all three of them.
A 14-foot ladder is used to scale a 30-foot wall. At what angle of elevation must the ladder be situated in order to reach the top of the wall? So, angle of elevation is when if you look up an object, the angle your line of sight makes with an object is called the angle of elevation. In this case, I am looking up but my height isn't given. Therefore, I can estimate that my line of sight will be same as the ground level, which will make the angle of elevation right around there. So, looking at the properties of this triangle, I've noticed that we can use the previous laws that we can use, the sine law. So we can also write it as sine 90 over 14, the 14-foot ladder, and sine of angle of elevation over the 13-foot wall. So we can simplify it more by writing it as 13 over 14 times sine 90, which is also 1, which equal to sine of the angle of elevation. And we can write this more simply by writing arc sine of 13 over 14 will be equal to the angle of elevation. So using calculator, if I write it as 13 over 14, they'll probably get a value which is close to 68.2121. So the angle of elevation will be around 68.21.
How?
We are Mungwas.
Of, let's say, tangents. Daniel, Daniel, you won. You killed Mr. Pink. But you got popped.